Now this is a concept in the MATLAB I want to discuss for the symbolic computation. So this provides an easy way also. If you want to do the plotting, then with the help of the ezplot. So ez stands for the easy plotting. So see, if you go for the normal plotting, then you have to set the axis, you can determine the number of points, and then you can go for the plot. And easy plotting means with by default range, and it is going to plot. So suppose S is a symbolic expression of x, then ezplot, like you have the plot function and you have the ezplot, x minimum and x maximum. So this will plot x between the limits of the x minimum and x min, and the easy always use the range this. So you can keep the range. This is the ezplot, use the range. Minimum is minus pi, 2 pi, and maximum is 2 times pi. Remaining thing, labeling the axis, title, and keeping the labels and usual way of holding up, hold on, grid on, everything. Subplot concept can also be used for this. So everything you can use with the help of the ezplot. So this is very important. Let us see, this is the example. The equation of a circle can be expressed implicitly as x square plus y square. This is the equation for the unit circle. And if you want to construct the graph for this case, so you know that you have to determine the x and y values. So you can solve for the y, but this is not necessary because you have the ezplotting. So this is the command ezplot. So ezplot, and you have to write this is in the form of the symbolic expression. And now you are giving the range minus 1.5 to 1 minus 1.5 to 1.5 within this range, and you have not determined any x point and y point. So very simple way you can plot. So this is, you are getting the answer. Sometimes you want to go for the easy plotting also. Now the circle can be expressed as parametrically as this is x is equal to sine t. This is the parametric equation of the circle. So x is equal to sine t and y is equal to cos t. And then you can go for the easy plotting, ezplot. So you can see like sine x, cos x. And simply you have not determined the anything. So very easy way you are going to plot. That's why it is known as easy. So by default range, actually it is going to construct the graph. So these are the various plotting function available for using the ez. So with the help of the symbolic expressions, you can use the ezplot. So ezplot can be used with the symbolic expression. So this is the simple plotting function. And mass function, if you want to plot mass, ez mass. If you want to plot the mass and contour, then you can go for the mass and contour. And then you can go for the surf, easy surf and contour. This is surf and contour. Contour plot, and you can have the contour surf, contour and surf. Plot 3-dimensional. Instead of 2-dimensional, you are going to 3-dimensional. And then polar graph. So these are the various functions you can practice at home. Now, if you see that, you are going to see the demonstration for simple. Clear all, close all. You are writing the script like this, CLC. So clear all, close all, CLC, all the variables, clears all the variables, close all the graphics file, CLC clears the command window. Now Z1. This is the symbolic expression. So this is the symbolic expression you have. You have 3 into 1 minus x squared exponent like this. And this is the symbolic expression. Here no need for the dot operator, you know that. Now Z2 is also the symbolic expression. So this is the Z, Z2. This is Z2. Okay. And you know you are writing the sim. With the help of the sim, you are going to create the expression, symbolic expression, and this is Z3 is the symbolic variable. It becomes the symbolic variable which is assigning this expression. So this is the expression. So Z3 is now Z with the help of the Z1, Z2, and Z3, you are getting the Z. What you have done here? You have just three symbolic expression Z1, Z2, and Z3. How you have obtained? Using the sim function. And you know that with the help of the sim function, you can do like this. So in the argument of this function is the string actually, and this becomes this expression is going to assign this variable, and this is assigned to Z2 and like this. And then Z again, Z is the symbolic variable which taking the expression like this, Z1 plus Z2 plus Z. This is. Now you know the subplot. The grid is 2 by 2 grid. You have the 2 by 2 grid now. And this is 1, 2, 3, and 4. So 2 by subplot 2, 2, 2, 1, 8 here. What you want? You want to mass plot of Z. So you have the mass plot of Z. So Z you have computed earlier. So you have computed the Z. Now you can give the title is EZ mass, color is blue, font size 16. Okay. Subplot 222 means at this location. EZ mass and contour. You are going to say mass and contour for the Z. And again you are going to give the title EZ max, massy contour. Sorry, color is the red, font size is 16. Now subplot 223 at this location. You are going to go for the surf. EG surf. You have the Z. And you are writing the title EZ surf. Color is this. You are specifying the pilot register value. This is the register value. Now subplot 2 to 4 at the location this. You are going to surf CZ. And you are. So see, with the help of this, you don't require to compute the X values, Y value, and simply it will do everything, and you are getting the answer. So this is the mass, is it mass, and in this location mass and contour, and this is the surf. Okay, this is the surf, and this is the surf and contour. So you are getting. So everything, whatever is the default range it has, and on taking those default value for the X and Y range, it is going to compute like this. X is equal to, this is the symbolic expression you have. This is the symbolic 4 plus 3 cos V into, like here, from here to here, then sim, this is the expression, and then Z, this is the expression. So X, Y, Z. So this is the X, this is the Y, and this is the Z. Okay. Now you want to surf plot easy with the help of EZ surf X, Y, Z. So you can give the title in the boldface, parameterize EZ surf. And once you run this, you will get the answer like this. This is the answer. Now you have seen that various capability of the symbolic computation. So with the help of the symbolic computation, you can compute, you can solve the equations, you can simplify, you can expand, you can substitute. Okay, you can multiply the two expressions, you can divide the two expressions, you can add the two expressions, you can find the differentiation, you can find the integration, you can solve the differential equations. Okay, and you can also find the system of linear equation. And with the help of the symbolic expression, you can use the EZ command, EZ plotting, and with the help of the EZ plotting, very easily you can construct the 2D or 3D graphs, for which you need to determine the points for the axis. But in the case of the easy plotting, whatever the default values are there, using default range X and Y, it is going to plot. So sometimes you may want to go roughly for seeing the graph, you can do like this.